Alright, so this is the video with the additional examples for lesson 7.3, which is using the distributive property. So I'm going to go ahead and walk through these ones. Again, this is optional, but if you're getting confused or you wanted to see a few more examples of this, that is what this is for. Also, you can use this video as an answer key and attempt to do these without watching each step by step, and then just use this to see if you got the answer correct. So we're going to go ahead and start here with our first example, which is 2 times the quantity of x minus 7 minus 10 equals 12 minus 4x. And so first thing we're going to do is use our distributive property. So we're going to distribute that 2 inside our parentheses with each term. So 2 times x is 2x minus 2 times 7 is 14. Minus 10 equals 12 minus 4x, because I didn't change any of that. Then I'm going to combine terms. I'm going to simplify by combining terms. If they are on the same side, it's just a matter of combining them. So here I've got these on this side of the equal sign. I've got negative 14 minus 10. So that's going to simplify to 2x minus 24 equals 12 minus 4x. All right. And now I'm going to go ahead and solve using inverse operations, combining my like terms. So I'm going to go ahead and nope, I'm going to go ahead and start with my other one. And it doesn't matter, again, guys, you can start anywhere as long as you are making sure that you are using the correct operation. I'm going to go ahead and add my 24. And the reason I decided to do that is because this is negative here, I just want to go ahead and turn it into a positive, right? So it cancels out on this side. So now I've got left 2x equals 12 plus 24, which is 36, minus 4x. Okay. So constants are combined. I need to combine my variables. I'm going to add 4x to both sides. And I'm adding because this is a negative 4x. Minus 4x, we're treating like a negative 4x. So it cancels out on this side. I've got 6x on this side equals 36. I ran out of room. I'm just going to rewrite that here. 6x equals 36. This means 6 times x, so 6 multiplied by x. The inverse would be division. So 6 divided by 6, 6x divided by 6 is x, and 36 divided by 6 is 6. So my solution is x equals 6. I can always check that by plugging it back into my original equation, and the answer on both sides of the equal sign should be the same, and that means that my solution is correct. Now I'm going to go ahead and move on to this example here, my second additional example. And again, there is 2 options here. You can distribute first and then eliminate the fraction, or you can eliminate the fraction first and then distribute. We're going to go ahead and eliminate the fraction first, and that means we're multiplying both sides by the least common denominator. In this case, that's 5. So we're going to multiply 5 times 3/5, and that times the quantity of t plus 18 equals 5 times negative 3, and that times the quantity of 2 minus t. Okay? So I'm going to take care of this first. Remember, I multiply a whole number by a fraction. I can cross cancel with a greatest common factor. Greatest common factor of 5 and 5 is 5. 5 goes into 5 once. 5 goes into 5 once. So now I have 1 over 1, which is 1, multiplied by 3 over 1, which is 3. And I have 3 times the quantity of t plus 18 equals 5 times negative 3, which is going to be negative 15, times the quantity 2 minus t. Okay, now I'm going to distribute. So I distribute that within each term in the parentheses. So 3 times t is 3t plus 3 times 18, which I'm going to plug in here. 3 times 18, double check my work. 18 times 3 is 54, equals negative 15 times 2, which is going to be negative 30, minus negative 15 times t. Now when I've got a negative times a negative, that is a positive. So that is positive 15t. Now I'm going to combine like terms using inverse operations. I've got 3t on this side. I want to combine it with my 15t. It is positive on this side, so I'm going to subtract 3t from both sides. And again, you could start with any term. I just chose to start with this one. And then what I've got left is 54 equals negative 30 plus 15t minus 3t is 12t. So I've got these combined. I need to combine my constants. I'm going to add 30 to both sides. And I do that because I can't move my 54 because then I have nothing left on that side of the equal sign. So I've got 84 equals 12t. So since that is 12t, that is multiplied, 12 times t equals 84, I'm going to go ahead and divide by 12, both sides. So I've got 84 divided by 12, which is 7. So 7 equals t. So that was a little bit longer, but we got there. Again, you can always check that by plugging it back into your original equation. And if one side equals the other side, the solution is true and your solution. So this last one that we got here is a real world situation where the Smiths are spending 8% of their budget on entertainment. Their total budget this year is $2,000 more than last year. And this year they plan to spend $3,840 on entertainment. So we've got 8% of their budget on entertainment, which should be equal to $3,840, but we don't know what this year's budget is. So we're going to go ahead and set up an equation. And we know that this year they want to spend this much. So $3,840 should be what they spend, but we are trying to determine what the total budget was last year based on this information. So 8% as a decimal is 0.08, so 8 hundredths. So we're going to go ahead and take 0.08, multiply it by last year's budget plus 2,000, because last year's budget plus 2,000 should be equal to what they want to spend this year, which is 8% of this year's budget. This year's budget, 8% of last year's budget plus 2,000. Okay? And that total should be $3,840. So what I'm going to do is I'm going to distribute that inside the parentheses. So I've got 0.08x plus 0.08 times 2,000 which is 160 equals $3,840. Now I'm going to combine my like terms. So I've got this canceled on this side. I've got 0.08x equals 3,840 minus 160, which equals 3,680. I'm going to divide that by my 8%, my decimal of 0.08. And I'm going to have x equals 46,000. So their total budget last year was 46,000. That's a lot of money. So they want to, so 8%. So if I plug this back in to my original equation, where 46,000 was their original budget, they're going to add 2,000 to that for this year, multiply that by 8%, and that should give them their total entertainment budget this year, which should be 3,840. One second. So again, you could have, here, if you wanted to, you could have eliminated the decimal by multiplying everything by the smallest place value, which is hundredths, right? Tenths, hundredths. multiply this by 100, multiply this by 100, multiply this by 100, and that would have eliminated your decimal. We know from our previous examples that would have given us the same solution. So it's really up to you if you want to work with the decimal or not work with the decimal. But make sure that you're keeping track of your signs, you're keeping track of your decimals, and that you're checking your work along the way. Because remember, we can check this. We could plug this back in. We could go 0.08 times 46,000 plus 2,000, and that should equal 3,840. And if it does, if this side equals this, then our solution is correct. All right, that's all I've got for you guys. Remember, if you have questions, write them down, bring them into class, and we can go over them. I will see you in class.